Today you're going to be working on your notes, and it's going to be data representations. Our objective: let's represent and analyze data using dot plots, histograms, and box plots. You want to have that handout that we did, that flip book handy as we go through these notes. So to start, tell me what you notice and what you wonder. The dot plot, histogram, and the box plot summarize the hours of battery life for 26 cell phones constantly streaming video. So one of the first things that we can notice is that all of these diagrams represent the same information. So one of the things that we can notice too is that they all represent the same thing, but they don't all look the same. When we look at the box plot, we notice that it has a line of symmetry down the median. If I were to fold this in half along the median, both sides would look the same. But the histogram doesn't. The same is true for the dot plot. When I look at the dot plot, it doesn't have a line of symmetry either. We can also see how the dot plot and the histogram are related. We see our first interval from 2, but not counting 3, and that's where we see just 2 values. So 2 cell phones. And then we see this section here, which corresponds to this interval, and then this one. So they look the same. And then finally the last intervals. From the dot plot, we know that this is our minimum. So the minimum is 2.5 hours. The maximum is 6.5. The mode is the one that we see the most, and we see that the mode is 5.5. We can see that the shape of the distribution is going to be pretty much symmetrical. Similar to that bell-shaped curve. Okay, now let's focus on some of the things that you might be wondering. Okay, maybe one of your questions can be, why are the intervals in the histogram 1? Instead of 2. One of the things that you might be wondering is what brands of cell phones were tested and how old were the cell phones. Okay, once again, take out your notes, and we are going to complete this frequency table. We're going to be doing a histogram based on tomato plants. They're giving us all the data, and the data represents the number of days it takes for different tomato plants to produce tomatoes. Use the information to complete the frequency table. You can look over that little flip book just to help you remember what we need to do to create a frequency table. One thing to keep in mind when you're doing this frequency table is that this interval goes from 40 to 50, but 50 is going to be counted on the next interval. So right here, when I'm putting in 60, I would count 60 on the interval going from 60 to 70, not the one from 50 to 60. You guys should be able to compare your frequencies. Should have had 1, 4, 9, 9, 6, and 1. Go ahead and create your frequency table, your histogram, based on the frequency table. Our first interval starts from 40 to 50, so we know that we're going to have the gap. And I only have one tomato plant going from 40 to 50. The next interval has 4. You might want to use a ruler to make sure that your values are the correct height. Okay, they're asking us to use the same set of data, but then instead of using intervals of 10, we are going to be using intervals with a width of 5. How is that going to change the histogram? Okay, this should be your final histogram with intervals of 5. So what are some of the things that make it different from our previous histogram? So one of the first things that we notice right away is that it has more bars. But with the more intervals, we kind of get a better feel of the distribution of the shape. Now, when creating the histogram, we can encounter problems if we have our intervals that are too large, or if the intervals may end up being too small. If they're too small, we're basically going to end up with a dot plot. But if they're too large, we might not be able to see the shape of the distribution. So one rule that you want to remember is that your intervals, when you're selecting your intervals, you want to have at least 5. So the first histogram that we did would be okay because it has at least 5. It has more than 5 intervals. And if we make it too small, like I said, we're going to end up losing the shape of the distribution or seeing just something very similar to a dot plot. Now you're going to use the same information, but you are going to create a box plot. So remember, for this, we're going to need our minimum, Q1, medium, Q3, and then the maximum. So go back to the information that we had, where we have our list of data. And the good thing, it's already set in order from least to greatest. So I can see my smallest value. So here's the minimum. And I can see the maximum value. We can go ahead and put those into our box plot. I forgot the other one. 47 and 90. Go ahead and find Q1, the medium, and Q3. We have a total of 30 values, so I would have to have 15 on one side and 15 on the other. There isn't a middle value, so to find the median, we need to think of the number that's in between 70 and 72, and that would be 671. When we look for the middle of the first quarter, we are going to need 7 values. 7 values on one side and 7 values on the other. So in this case, we do end up with a middle value. So Q1 would be 62. The same thing happens with the second half or the upper quartile. So our middle value would be 78, and that would be our Q3. Okay, I don't have a lot of space to write these down, but it says, what does the median represent for this data? So I know that the median is the middle, and this is counting the number of days it takes for the tomato plants to produce tomatoes. So in this case, it took 71 days for at least half of the tomatoes to produce tomatoes, and it took half of the other plants more than 71 days to produce tomatoes. Okay, for our Q1, we have 62. So that means that 1/4 25% of the plants took at least 62 days to produce tomatoes. Okay, this next part of the question is not asking us to define what it means in this situation. They just want Q3, the minimum, and the maximum, and we already found those values. So using this 5-number summary, go ahead and create the box plot. Remember that to create it, we're just going to put tallies on each one of these values. So 47 would be somewhere around here. 62, 71, 78, and 90. Q1, the median, and Q3 make up the box. What are the strengths of each of the representations? Now, we didn't do a dot plot of this, but for a dot plot, one of the strengths of the dot plot is that I can see all the values. So like I said, the dot plot shows all the individual values. In a histogram, it gives us a summary and it shows us the shape of the distribution. The box plot provides us with that 5-number summary. Now the weaknesses, dot plot might take a little bit longer to construct. It has too many columns and too many dots to put in. So it might make it a little bit more difficult to see that 5-number summary right away. The weaknesses with the histogram and the box plot is that they did not provide us with the individual data. Makes it hard to calculate things like the mean or find the mode. How do you find the typical value of a data set? Now remember that what's typical, that's going to be our measures of center. So we're going to be focusing on the mean and the median. To find the mean, you know that you find the average, add up all the values and divide it by however many values you have. To find the median, you're always looking for the value that's in the middle. What information can be seen most easily in the dot plot? Individual values, we can see the minimum, maximum, and the mode. What information can be seen most easily in the histogram? Shape of the distribution. What information can we see in a box plot? Of course, we have our 5-number summary. So we have the minimum, Q1, the median, Q3, and the maximum.